So today we start with the topic of the mobile thermal energy storages. And I'm very happy that we could win two speakers from two different companies. One is Christian Kissling from Kraftblock, and the following person is Tobias Schmid from swilar eetec.
Okay, thank you very much, Ms. Staffelmeier. It's a pleasure for me to give you an introduction about the mobile heat application of our Kraftblock mobile heat storage. Just double check, can everybody see it?
Yes.
Okay,
yes.
Perfect. Good, great. So heat is a big thing in line of the decarbonization. It is only limited touched. A lot of focus goes on decarbonizing on the electricity, electric vehicles, batteries, hydrogen. But at the end of the day, heat is the perspective, and we have to find a solution how to overcome the not easy way to decarbonize the heat, which is a major portion in the industry and a major portion in the global emission coming from heat. And one of the solutions is heat storage, and the special topic of the solution would be the mobile heat storage. So our heat storage, as an overview, is a very multifunctional application. We can either tap the waste heat, or we can take the electricity, especially the green electricity, to charge our storage unit, and then have it served as a process heat into industries, or for district heating, or even a possibility for putting it back into power generation. And of course, mobile services also is a quite interesting thing. In this case, not for putting it back into power, but for all applications in the field of heat, process heat or building heat. A few words to our own storage system. So our storage system has a speciality that we can take the heat up to 1,300 degrees. Preferable, we take the temperature starting from 350 degrees when we talk about taking a waste heat from some industrial processes, and we can go up to 1,300 degrees. We have a modular scalable storage system, as you can see here on the picture in the middle. Either we have for example, a 20-foot container, which also would be the solution for the mobile application, or if we have it as a stationary one, we would put several containers together. It looks like several containers from the outside, but at the end, it would just have the appearance on the outside of several containers, and inside we would take out the dividing walls to have a larger inside storage compartment. Our storage material has a very low CO2 footprint. We are not using any raw earth. Our storage material also has a very high energy density at 1,300 degrees. Just the storage material itself has a capacity of 1.2 megawatt hours per cubic meter. But at the end, we talk about either some pellet application or some other geometry where our material will be produced and then be put in a kind of packed bed or in a containment inside the storage. Our material, we have tested several cycles, and there is no fatigue syndrome in that respect. And also, what is the advantage of our material? We are using up to 85% of recycled materials. In this respect, looking to the slag from the steel or from the glass industry, which is a major component of our material. And this also is the reason why we have a very low CO2 footprint in our material, because we take recycled material from a process which already has counted the CO2 value in the other processes. How does this storage work? So we are operating with hot air or with hot flue gases as a charging medium. So in the first illustration, you see the hot air or the flue gases is blown through the storage, and by the heat transfer from the hot air, the heat is going directly into the material, and this is the way how a storage will be charged, and the heat is going from the left hand to the right hand. And when the storage is fully charged, we are in the position to store the heat up to a duration of maximum 2 weeks. And for the discharging side, then we take the cold air We go into the storage system, we push the cold air through the storage material, and the heat is going out of the storage material into the air and then is served to the downstream process. Okay, so far for the storage principle itself. Mobile heat, especially, so this we see the decoupling not only time-wise but also location-wise, which is opening new opportunities, and it's ideal solution for applications where direct access or to waste heat sources is not possible, and also for the companies who have a lot of waste heat. There could be a new business model if selling waste heat for other industries and utilities. So the advantage just with the mobile heat is connecting the energy points. We can save primary energy with also the savings in the emissions as well as the costs, and no new energy source is needed. And especially talking about waste heat, we talk about the glass industry, steel industry, ceramic industry, brickwork. So all the industries which have very high heat, which could be tapped in our storage and then also used as a mobile one. So making heat mobile, this is the application on the street, which can very easily connect sources and sinks. So we can take up to about 5 MWh into our mobile applications. We have designed a docking system for easy handling and easy automatic connection on the charging as well as on the discharging side. And we have some limitations when we talk about mobile heat on public roads. Of course, we have to obey the transport weight limits, which is in Germany 40 tons. So we only are in the position to load a container about 60–70% due to the weight limitation. On the other hand, if you have, for example, a glass factory with very long distances, also it could be an idea to say we take a waste heat from one source where it's very hot and we transport it all over the area of the glass factory to another place. And when you are on your own premises, you are also allowed to go higher in the transportation weight, which then will allow you to take more heat capacity in the storage system. And we also even had a client who was asking about why you don't consider about putting the containers on the train. So just for this client, we made a little bit 3D animation. This is something which could be a situation in the future where we would be in a good position to transport much more energy. Of course, we should not think about long distances, because by the train transportation and the air going around, the cooling and the lowering of temperature may occur in a much higher effect. But just if it's about whatever 10 kilometers away from one to the other, this might be a good application to go. So the mobile heat projects that we have realized, this is our pilot, which we have together with our partner company close to Hamburg. We take the heat from the exhaust of a biogas combined heat and power plant. It's an engine, a biogas engine, where we can take the exhaust and bring the exhaust through and directly bring it into our heat storage system. And the pilot has about 1 megawatt net capacity. In the series, we are aiming to go for 2 to 3 megawatt. And we have related saving potential as we have written over there. So for the customer, it's good that they do not waste the valuable energy from the CHP plant. Very often the exhaust from the CHP plant are only used to heat up water, which already is heated by the waste heat from the engine, from the oil cooling and the water cooling. It's already heated up maybe to 80 degrees. And then just the exhaust energy is heating it up to 95% or something like that. But there is no need to heat water to such a high level. So this exhaust energy could be used for this mobile application, which then creates a new business model. is a saving on emissions on the one who is benefiting from that heat. And in this case, we made a quite small container, as you can see, because we were adapting it to the fleet of our partner. So the second project, this project before we have realized in 2020, which was a pilot, and we are waiting for more orders to come. And this project here, we somehow, this is a funded project from the European Union, where we are working on utilization of flare gas, which is coming from a steel mill. And the idea is to take the energy from the flare gas and use it for our own fabrication hall in Germany to heat up our heating system and replace the oil heating. So the interesting thing, how are we doing it? We take the flare gas, which is a converter gas from the steel making process. We are getting the cleaned converter gas from the client at his location. We put it in an adiabatic combustion chamber, and adiabatic combustion chamber means we are combusting it without taking away any energy. So the flue gas temperature is about 1100 to 1300 degrees of that combustion process, and we take the high level temperature energy, put it into our mobile heat application. And the idea is to tap the energy in the steel mill on a weekend, on a Sunday, and then bring it to our own workshop, which is about 10 kilometers away, and then have the energy there for the heat supply of 1 week during winter time. And the flare potential at the steel mill is the flare potential in general in Germany is over 100 gigawatt hours a year. So a lot of projects like this could be realized in order to get rid of a flare gas on the one hand side, and on the other side to do a big contribution for CO2 savings, because we as a user of that energy, we do not need to use any oil heating. So the flaring we have in biogas plants, chemical industry, refinery, steel mills, as I said, waste disposal sites. So there's a very big potential, and we think this is something also where we can make even better use than from the biogas CHPs. Another mobile heat concept, now we are looking on the electricity side. Very often we are realizing, especially in Germany, is the situation that the wind power will be curtailed. That means when there is too much electricity and power in the grid, the wind plant operator are asked to shut down their plants, even they don't want to shut it down. Even they get compensated by this political regulatory. But on the other hand, the interest is to have it up and running, and somehow the idea is to use that heat in a kind of off-grid application, where we say we make a bigger storage close to the windmills, and in case this curtailment is announced from the grid operator, then the heat will go into a larger storage, and from that larger storage then a smaller container can be charged and bring it to the sink close nearby the windmill park. Okay, and I'm already coming to the end of my presentation. So the heat sources for mobile heat is the waste heat from the industry, from biogas plants. A big eye is on the flare gas, as well as on this renewable power, as I just introduced about the wind application. And the sinks is within the heat industry. So all process application, either hot air, either thermal oil heating, or maybe even steam production could be possible, but it's very applicable in also public swimming or wellness facilities, large buildings and quarters, or also for district heating, as especially the district grid operator now are facing more and more the challenge also to get greener district heating on the one hand side, and on the other hand side, the fossil-fired assets presently and in the past feeding the district heating are not available anymore. So they are on permanent look also for the district heating application. Also for district heating, for example, if a client in the district heating system is looking for new clients, also the mobile application could be a good starting point if they want to get new clients, as long as a new district heating pipework is not realized and is under approval. At this time, it could be a solution, a temporary solution for maybe 1 or 2 or 3 years, just to transport the heat from the source to the new clients, and later on have enough time in order to install related pipework. The key to all of this mobile transportation is what we figured out is to find a low transportation cost solution. So this always is a key in order to avoid that the transportation costs are eating up the energy value at the end, which we are transporting from A to B. And from our experience, the distance should be between in the range of about maximum 10 kilometers. But as I said, this is depending how the transportation solution will be. Very often when we talk about agricultural business and agricultural clients who have people available who could go with a truck from A to B, coming back and forward throughout the day, I think this is a very suitable one. If you need to engage a third-party transportation or logistics company, then this is very difficult to achieve a sound business case. Okay, and here are still at the end my contact data, and so I'm also ready for questions now or of course later on. Thank you very much.
Thank you very much, Mr. Kissling. This was a very nice overview in the also the ongoing projects and the working scheme. Mm-hmm. Yes, I need to say I'm a fan of that. The material has this very low CO2 input. Let's say, I don't know.
Footprint.
Thank you. Yes. Very, very nice to hear that it's on the one hand recycled and that it's no raw material. Mm-hmm. I think it's an important factor to consider as well. If it's possible, it's perfect to do in this way. So yes, many thanks again. And I saw there's already a question. Mm-hmm. In the chat. Two now. So I start with the first one from Cristobal Villasante. He said, should transporting materials at very high temperature be considered a hazardous material? Mm-hmm. Are there regulation limitations?
Very good question. We of course have checked in Germany with the related authorities for transport. It's a special department. I forgot the name, but at the end of the day, it's just declared as a transportation of hot stones, something like that. So it's not explosive. It's not hazardous in regard of any burning or fire. Of course, in case there will be a very heavy accident on the street and it may fall over and the container may open. The only problem is we have hot material being released on the street or on the grass, and maybe just by the hot temperature, this could be kind of risk of fire. But the declaration as itself is it was no big hurdle to take.
Okay, many thanks. Mm-hmm. But a very interesting part to think about, indeed.
Of course.
Mm-hmm. The second question is from Mr. Sautier. What is the density of the storage material?
I don't have a figure about the density. No, I cannot tell. It's depending. When we go, for example, with pellets, it is depending from the packed bed density, or is depending from the diameter of the pellets we have, and we are adjusting each case in line with the given temperature level, with the given topic of pressure drop and something like that. So this is not any standard value we have at that stage.
Okay, thank you as well. So one more question. Okay, with this name I have problem. Now that we have two. So the question is, could it function as a snow melting truck as a substitute for road salts, for example?
So we are not taking, that's a good question. We are not taking out the heat during transportation. So in case this would be something to think about, just to serve the hot heat from the truck on the ground, it's a very nice idea. We may need to think about a discharging equipment to be installed on the truck in order to serve the heat downstream on the frozen ground. But we have never thought about.
Sounds like a very different
a new application,
but
yes.
Still, I mean, if there is some heat to be released and there is a use to make out of it, it's still it's an interesting scope maybe to think about.
Yeah, it's I like the question. Thanks a lot for this one.
Especially, I can see that the person who asked the question is from Norway, so I guess
yes,
this is quite
yes,
a more urgent topic there. Yes.
Yeah. Especially saving the salt, no? That's the
exactly.
issue.
Yeah. Also from an environmental point of view as well. Yeah. And
maybe just one note.
Yes.
I didn't bring in my presentation. Even we take the heat 800 degrees, 1000 or 400 degrees, whatever it is. When we talk then about the discharging on the sink side, we have outside of our storage, we have then apparatus in order to come down to the intended temperature. So either maybe for hot air, 140 degrees, or maybe for steam production, we need maybe 350 degrees. So the storage temperature itself is a different temperature than the temperature which we have in the downstream application. For example, the flare gas, as I said, we are taking 1200 degrees into our storage system for the transport. So meaning the higher the temperature, the more dense the energy is, the more energy we get in the 20-foot container. But on the discharge side, in the docking station at our workshop, we will have a so-called mixing chamber to mix down the 1200 degrees to 80 degrees. And this 80 degrees goes to our air heating system of our fabrication hall. So in regard for the street topic, what the gentleman was just asking, we could, for example, then go down maybe to a temperature of maybe 90 degrees, not damaging anything on the street, but having enough heat to get rid of the snow and ice on the street, for example.
At least temporarily, if it's not getting cold again.
Yeah, yes, of course.
But I think for something like defrosting any things in a quick way, it seems quite usable.
Yes.
So we have a couple of more questions. I will make at least let's try two. Maybe if we can have more. If not, maybe you can try to answer in the chat or later on. So the next one would be, what is the lowest, or maybe it's the next one, sorry. What is the lowest interesting relevant charge temperature? And a following question, what would insulated containers increase the possible distance? And would insulated containers increase the distance? Okay,
two things. The lowest temperature for charging, we are looking at about 350 degrees. As I mentioned before, the higher the temperature, the smaller, the higher the energy density, the more megawatt hours we get into our storage system. And secondly, of course, we do have an insulation system in our containers, in all storage system. We always have to make sure that the surface temperature outside of a storage, either mobile or stationary one, is not exceeding about 50 to 60 degrees Celsius.
Okay, perfect. Many thanks. Especially as this also answers the next question, what the surface of the container, the temperature is. So we have answered this as well. So I think that there's one more question, which makes a very nice bridge to the next speaker. And it is asked, is it PCM or with marks only sensible heat storage?
So we are the one with the sensible heat storage. And the one with PCM will follow right after me.
Exactly. So many thanks. Thanks for the question. So yes, many thanks for your talk as well. I think then we can move directly on to Mr. Tobias Schmid. You can share your screen.
All right. Hello, everybody. Now from high temperature from Kraftblock now to a lower temperature mobile solution for waste heat. We are regularly in contact with Kraftblock, and we find our solutions in high grades as supplementary, more or less. So anyway, we have with Kraftblock many common questions concerning costs and structure to get into the project. So my name is Tobias Schmid, and I'm happy to be here with you today. I'm General Director of swilar eetec. eetec is a spin-off of a volunteer association from the German Energiewende. It's the Landsberger Energie Agency. So it's based in south of Bavaria, 50 kilometers from the Alps, 50 kilometers from Munich. And contrasting now a little bit to the focus of Mr. Kissling, we started not with an industrial approach, but with a simple regional focus, a focus on rural areas. Our first target in 2014, when the association was founded, we focused on the most efficient way in our region to reduce carbon emissions. And after some years of discussion and moving ideas in the agency, we found in rural regions like ours that the heat sector is the most inefficient and has to be the main target for our energy transition. Focusing on heat energy, we came to the conclusion that waste heat is one of the best and most simple to use resources we have in our region. We have, for example, in Landsberg, 26 biogas plants, and half of it have no heat use at all. Then we have other 5 industrial plants in the region with waste heat potential for more than, let's say, 2,000 households in the region. So when we expand this information from our regional side then to a national level in Germany, we estimate that we have waste heat potential in Germany for around 100,000 terawatt hours. The figure is based on research of the German Energy Agency and the Forschungsstelle für Energiewirtschaft in Munich. And when using this waste heat potential, we could supply heat energy to nearly 10 million households in Germany. Coming to the actual challenge to reduce fossil energy supply from Russia, we estimate, for example, that we may substitute 40% of oil imports from Russia, with consequently using Germany's waste heat resources. So the 130 terawatt hours is all temperatures levels. So the one which Mr. Kissling mentioned as the one we are running with. I start with, this was too fast, sorry. So what we do is with founding swilar eetec, we presented in 2020 a new mobile system for transportation heat energy, which is so far approved by the TÜV, the Technical Inspection Agency in Germany, and registered for a patent. We developed a tank on the trailer filled with phase change material. It is a salt water solution based on natrium acetate, which is on the one hand quite easy to handle, and second important, with no threat to the environment. The phase change is about 58 degrees Celsius, so our system operates in low temperature level between 30 and 100 degrees Celsius. It is fitting ideal to all modern low temperature heating systems with requirements under 50 degrees Celsius in the system. The most important thing with our storages is we improve flexibility of energy, and not only in time, but as well in space. So all systems, storage system usually focus on time, but with our system, and as well with the system from Kraftblock, we have a flexibility in time. And this is quite important to mention, because all the subsidy institutions which we have, they focus in storages only on time storage, but not to move from one to another place. With one turnaround in our storages, we can transfer up to 2.5 megawatt hours into a heat water cycle of the consumer side. The shortest duration time is 6 hours for filling up storage and about around 8 hours to extracting the heat energy. So usually we have one couple of storages in one system. So this is the minimum setup. And with one setup, we can move in a year about 1,500 megawatt hours. And the temperature level between 30 and 70 degrees is on the demand side, which is perfect for us. Going a little bit deeper into our temperature and power system. So I have brought this diagram. On the left side, you see the temperature level. On the right side, you have the thermal power in kilowatt. And down below, there is time in minutes. So this is one unloading circle with around 6 hours. So you can see we start with around 100 degrees, have a sensible extraction warm, which is going down in the first 1.5 hours to the phase change temperature level around 50 to 60 degrees. And when all the salt is getting hard, it's getting frozen, then we have another sensible part, which is around 300 kilowatt hours. Unfortunately, we start to substitute in any heating system, we start to substitute oil and gas systems, and they are usually above 70 degrees or 80 degrees. And we are perfectly fitting into a new heating system, but usually the most projects ask to substitute gas and oil. So the thing is that we usually should have a temperature level fix on around 60 to 70 degrees. And we have done some engineering on this point, and sometimes we use a heat pump to ensure this temperature level over the whole unloading time. So this is one supplement to get our energy into the systems. So what we can do operational, so what we can connect is for sure power and heat engines, so all kinds of BHKWs. I'm not very sure if I have the English pronunciation right, but power and heat engines. And of course we have biogas plants, geothermal energy plants, which is a quite dynamic market in the moment in the south of Germany around Munich. Then all kind of waste heat, waste handling operations, burning or some other compensation, and industry at all. So industry is always interesting if there's some waste energy. On the consumption side, the most target is all kinds of new heat networks. The best if they have a low temperature, lower 60 or 50 degrees Celsius. Then, of course, all real estate and living quarters which need more, let's say, more than 30 flats is interesting for connecting with the mobile heat storages. Public swimming halls is very interesting because we have a heat demand as well in the summertime. Hotels as well. All kinds of drying plants is also quite interesting because they have demands in summer. Hospitals, schools, and gyms, and greenhouses. So these are the actual project setups which we are facing at the moment. Coming a little bit to the direction of costs, what we found out, the best setup for us is not one couple of heat storages, but around 10 heat storages. So if we have 10 units in one cluster, it may be there is only one heat source, energy source, and several downstreaming several demands, or the other way around, that we have one very big demand side and several biogas plants, for example. But anyway, it's a cluster. And when we get to 10 mobile heat systems, then we have our lowest cost ratio in the whole project. The invest for this kind of cluster is 1.8 million approximately, and we can move in one cluster then something like up to 15 gigawatt hours a year. Coming now a little bit deeper into the cost structure, we have one example calculation made here for you with 2 mobile storages. We have a depreciation for 50 years calculated and the interest rate for 3%. The logistic turnover we face is usually between 80 and 100 euros per turnover. So this is 1 hour which the truck has to work on 1 turnover. So bring 1 storage to the source and bring back from the source to the demand side the truck. We have the same distance, around 5 to 15 kilometers, which we see as possible for our system. So in this calculation, the average cost is about 80 euros per megawatt hours, which is completely delivered, so complete costs. If we compare this a little bit to the market side in Germany, we see that we are here in the yellow side, that we are around 7 to, let's say, 9 or 10 cents per kilowatt hour, which we have to put to the customer. But what we have in gas prices in the last year, so this is not really high enough, because we had seen more than 20 cents per kilowatt hour gas as well. But we have to take in charge as well a carbon price, which will be implemented on the gas and oil prices. So I think with a mobile heat transport, we are always quite sure in a low cost level. So coming now to some projects which we are into it. So proof of concept was more or less in Switzerland. One of the first projects is we started in 2019. This is a public swimming hall which was built from the ground, so it will build new from the ground, and this was of course a perfect sink for us, because they made their whole system lower than 50 from a demand side, lower than 50 degrees Celsius. There was no backup system installed in the whole swimming hall, but they ordered 3 storages, so just to have something to be sure about. In the end, they work only with 2, so they are fine with 2, and the system is running now without any problems since 2019. The second project is directly in the neighborhood of Landsberg. This is in Kaufling as well, a swimming hall. We started a little bit later, but as well in 2019. And we expanded this project now to another swimming hall, which is only a summer swimming bathroom. So with this project, our last project we started last year, 2020, we have already 6 storages in place around Landsberg. And end of this year, we are happy to have another one. So I think end of this year, we come already to 10 storages in one cluster, and then we can start with our own logistic system to can show how deep we can come with the cost at all, because now we pay to a logistic service provider, and of course he has other cost structures than when we do it by our own, and we can optimize the logistic for the heat extraction. So come to all together, what we can do with our systems, we have a regional source cycle, we have a regional added value, we have reduced thermal emissions in the environment to rivers or to the air. and we have, of course, reduced carbon emissions. And so we get independent from any sort of global energy markets in prices and imports. We have very low carbon costs at all. And last but not least, we get independent from and more self-sufficiency. So this was some ideas from that what we are doing. I'm happy to have some questions from your side. Please go ahead. Thank you very much.
Oh yeah, thank you very much, Mr. Schmid. Very nice. Also here, many thanks to also give insights on projects which are already running to really get a picture of how it can be used and implemented in reality, not only in the head. So many thanks. I'm not sure if we have any questions. So you mustn't write into the chat. You can also raise your digital hand and ask something. I think the last two questions regard to higher temperature should be for Mr. Kissling maybe. So I give the audience a minute to think and maybe ask myself a question. So if, for example, there is already a swimming pool, maybe with a gym and so on, and this exists already, and they want to make use of your system, how much work would it be to, because they have to have this docking station, there must be some heat exchanger area, so how much work would it be? Is it a high investment for them to build this on their already existing swimming pool, or are there limitations?
Maybe let me come back to the, I have one more slide just to have it. Thank you for the question. So I was a little bit prepared for that question, but we have several systems as like mobile systems. This is something like, this is a 20-feet container, but
I don't see your screen now. I'm not sure. Do you share the?
Yes. I try again.
Something went. Oh yeah, yes, perfect. Thank you.
Okay, so we have several solutions on the supply and the sink side. We can install it inside if there's enough space for it. Otherwise, we can just put on a 20 or 10-feet container like this. It looks something like this.
Yeah.
The total cost for this is between 40 and 55,000 euros.
Okay.
This is what we have to invest on both sides. But in our calculation, which I showed before, this is included. So this installation are included.
Okay, very nice. And even wooden, if I see, so it's not even, so it can be even nice part of the already existing building. So
yes, usually on the source side, it's not that important. So we have some industrial stuff around there, but on a public swimming hall, of course, it should be a little bit nice to see. So
yes. Okay, many thanks for this. And so now we have a question from Tobias Schmid. The question is, how long can the system store the energy?
I forgot to talk about this. So usually we have around 3 to 5% losses per day. But our systems, if you come to the economic side, of course, we should go on and go on. So the system should not store the energy for days. This is not really the idea of it. So we have more a transportation system than a storage system. So, but in the end, it's isolated. The tank is isolated, and we lose something like 3 to up to 5% per day. So it's not too much. And it depends if you leave them the storage for 2 weeks. Of course, in the last day you don't have 3%. It's getting less and less.
Okay, thank you. I think it should be answered with this. The next question was, what is the lifetime of the system, especially the PCM reversibility? So yes.
We do not face any change of the PCM system because we have no. So it's completely closed. We don't have contact to the air. It's low pressure, so we are operating between 2 and 3 bar. But there is no change in the chemical structure at all. So we don't see, and we have just some weeks ago we had old containers from a previous factory, and the salt was quite new. So, and this was 12 or 13 years old. So we didn't find any problems with the salt.
Yeah. So quite sufficient stability in this case. Yeah.
So and everything in our storage, everything inside is Nero steel. So if we do not have any problems with chloride, we don't face any problems with this.
Perfect. So I guess it's answered with this as well. Okay, so it seems there's no more question. Maybe then I ask one more, just as I have the chance. And I'm not sure if you can talk about, because I saw, of course, you have the patent and everything. How is the PCM in the container structured? If you can talk about, I'm sure it may be some your own identity you showed, but yeah.
No, this is no secret at all. So it's called a Rohrbündel Wärmetauscher. It's kind of tube bundle inside, and it flows from the right to the left, so that we really get every inch from the salt in contact with the operational water.
Okay.
So we connect on the supply side the heat water, which is ideal between 90 and 100 degrees Celsius, and we connect as well on the demand side the heating water, which has something like 40 or 50 degrees. So this is the best setup.
Okay. Very interesting, thank you. So if there are no more questions, so I saw Mr. Kissling, thanks for answering in the chat. I guess this question should be answered as well. Yeah, there's one. No. Okay. The question with 90 to 100 degrees Celsius is ideal, but would it work with 70 degrees? So.
It would work, but we always have to consider the monetary side. So if we would lose this 20 degrees, so let's say every degree is worth 20 kilowatt hours, and it's every day, once, twice a day. So you can calculate how much you will lose when you are just on 70 degrees. So we won't touch it in the first run. So yes. It's when we get into the market, we try to check for the best system constellation we can find. And the best system constellation is a source which has the right temperature level on, let's say, 1 megawatt. And we find these sources. And I think we should use, in the beginning, we should use always the right packages.
Yes. It should be still an optimum on what you can have to deliver.
Very good, many questions come from, what is it, Rechenzentren?
Yeah. No, from the like
data center. Data
centers. Thank you. And they have huge amounts of heat energy, but this is usually lower than 70 degrees. And we have one engineered one project engineered with heat pumps to get it up to 95 degrees.
Yes, I think.
but we are on the run, so I hope it will work, because there is a huge amount of data centers which have exactly these problems to get their heat used somehow.
Yeah, I think still the is a broad field of sources of heat, and then it must be considered which system maybe fits best, and if it's also for making a use of a heat pump more efficient. Because now the person also wrote that there is in North Sweden, there's a large potential to electrolysis. So of course, if there's a huge potential, it makes sense to think about how to implement the 70 degrees in the best way. Maybe then different setups, and then it also economically makes a difference. If it's okay to lose a little bit of degree, but you have more available. Yes.
So the heat pump is a very good partner for our system. So as I say, with Kraftblock, of course, you have such a high level of work-able heat energy. So it doesn't, it's not that important if you use 300 degrees or 700, you just have the potential. We have to look that we get the right temperature level to load the truck, and that we get the right temperature to unload the truck. So we are a little bit more focused on temperature level at all.
Okay.
But for us, it's the most important thing. How can we compare with heat costs from the standard systems, oil and gas and whatever we have? Yeah. And we are sound below the actual market situation, and this is the thing where we see our chance for the market.